Let's do the structure of oxalic acid. Okay, step 1, skeleton. Now you're given the skeleton of this one. It looks like this. Alright, so there's the skeleton of it. Step 2, count the valence. So we have 4 oxygens at 6 apiece. We have 2 carbons at 4 apiece. And we have 2 hydrogens at 1 apiece. So we have 24, and 8 is 32, 34. Okay, so next step, if I'm using the color coding scheme, is connect. 3, connect. Two, 4, 6, 8, 10, 12, 14 I used up. So I got 20 left. All right. Next step. Satisfy the outers. Things on the outside of the structure. Okay, the hydrogen is happy just the way it is. It only wants 2. So's that one. This oxygen wants to have an octet, so it needs 6 more. 1, 2, 3, 4, 5, 6. This oxygen needs to have 6 more. 7, 8, 9, 10, 11, 12. So I've used up 12 in this step. I got 8 left. Okay. The next thing I do is dump the remaining electrons on central atoms. All right, let's see. I'm going to start with the neediest central atoms first. These oxygens need 4 more, and these only need 2 more. So I'm going to start trying to satisfy the oxygens. This one needs 1, 2, 3, 4 more. 5, 6, 7, 8. And I have used up my remaining electrons there. I have no more to satisfy these. Now, if you still have central atoms at this point that are not satisfied at this step, you've got to go and look at the neighbors and share them. So there's a lot of ways to share. This one needs 2 more. It could share here, or it could share here. And this one could share here, or it could share here. Now there's a lot of possibilities. There's 2 possibilities here, and then 2 possibilities here. So there's a total of 4 different ways for you to draw the structure. Let's weed out one of them right away. If you share up in this part of the structure, if you share here like this, you're going to get a little piece that looks like this. Right? That's what I'm going to get with this piece here. And I'm looking at just the oxygen here. If I share that lone pair, I'm going to get something that looks like this, and it's going to have a 6 minus 5, because there's 5 sticks and dots, a +1 formal charge, which is unfavorable because oxygen is a very electronegative element. So sharing on top is probably not going to be as good as sharing on bottom. I can see if I share on the bottom, I am going to get a 0 formal charge. So it is clearly better to share this one than this one. So I'm going to say, let's take this possibility off the table because it's going to produce a high formal charge. And let's leave it the way it was up there. And now I only have to deal with these. And I have to do both of them. So if I put that one down there, I'm going to get this. And if I put this one down here, I'm going to get this. And that is the structure. There are no resonance structures. I can see that this works out nice if I do the final step, which is to go ahead and assign the formal charges. The formal charges in this structure are 0 everywhere. So how many lone pairs are there? There's 1, 2, 3, 4, 5, 6, 7, 8 lone pairs is the right answer. So 8 lone pairs is what you should have gotten.